Hi, everybody. So this is we'll go over homework questions for the lesson on partitioning a line segment. I know that some of you might have some issues with this, and then this lesson I didn't really teach, but hopefully the video was very clear on how we're supposed to do these things. So the first thing I want to do is look at first question number one. It says, if point P lies on segment AB with endpoints at -5, 11, and B is 1, 5, such that AP to PB is 1 to 1, then P must have coordinates of, okay, well, if its ratio is 1 to 1, that would mean in this case that the segment AP and the segment PB must be equal. So point P must be the midpoint here. So point P, it must be the midpoint. So I'll make sure I get the marker on there. So P equals midpoint. And so here we use the midpoint formula, which is very similar to what we're doing, but we'll see later on how maybe it's a little bit different. So for some of the things we're doing. So we add the x's. Oh, by the way, midpoint formula, x1 plus x2 over 2, comma y1 plus y2 over 2. Okay? And so we take -5 plus 1 and divide by 2, and we take 11 plus 5 and divide by 2. And we're going to get, in this case, -4 over 2, comma 16 over 2, which we have to simplify. So point P is going to be at -2, 8. Which I'm pretty sure you guys had no problem with, but again, reviewing this thing. So the next question we're going to do here is going to be for number 2. RS has endpoints at 5, -3 and 5, 13. Point Q lies on RS such that RQ to QS is 3 to 1. Okay, which the following must be coordinates of Q. So we want to find Q. Now the ratio of 3 to 1 would mean in this case our distance from, now we can kind of sketch this here if we need to. So let's see, let's sketch this here. So we got to draw a line segment here, here, okay. And so we have in this case 5, -3. All right, so draw this up here. And so 5, -3, 1, 2, 3, 4, 5, 1, 2, 3. So 5, -3. And 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way up here. So 5, -13. Sorry about this, ladies and gentlemen. I probably could have done this a little better, but okay. So here we see in this case, this is a segment that's going to be this long here, and we want to find the point that breaks up the segment into a ratio of 3 to 1. Well, it's a vertical line segment, and we know in this case that the distance between here is 16 spaces. 16 spaces. And so the ratio of 3 to 1 would mean in this case, here we have we're moving in this case 3y plus 1y equals 4y. Now, why do I say this for? Because here the x's don't change, all right? So here 3y plus 1y is 4y. So we're going to take 4y is equal to 16 spaces and divide both sides by 4. We have, in this case, y is equal to 4. Now, when we have y equals 4, it really should mean the change in y, okay? How much we're changing in y. So here, the idea is that we're going here is a point R is the bottom here, and point S is on top. So we want to kind of find this, in this case, we're breaking into 4 pieces here. So here's 4 pieces. And so now we're going to go ratio of 3 to 1, RQ to QS is 3 to 1. So Q will be somewhere over here because here's 1, 2, 3 spaces to 1 space here. So Q is about here. And we know the X value doesn't change, so that's about 5. But we're going to go in this case, well, not 4, but here 3 times 4. So we're going up 12, okay? And so the idea now is that we'll take -3 plus 12 is equal to 9. So we're going to have our Q value at 5, 9. All right, so now let's kind of talk about this whole thing about we're trying to figure out how we do these problems. We're really looking at the following, and again, the person who came up with the work before probably told you, okay, so we have a formula, and so everyone approaches the formula a little bit differently, and so I want to kind of take a look at this and you know, kind of show some of the things we have. The idea now in this case, if let's say we have point A is x1, y1, okay? And point B is x2, y2. Right. So the idea now is that let's say point P divides. So in this case, we will say point P is between them. So let's say AP to PB is a ratio of, let's say, 2 to 1. Okay, so not the midpoint, but in this case, dividing ratio 2 to 1. So what we want to talk about in this case is our difference of the distance of x. Okay, so our distance of x is equal to x2 minus x1. Okay, so in this case, how far we're traveling from x1 to x2, it's our difference. And sometimes it can be negative values as a positive value. And our distance of y is y2 minus y1. Okay, and so these are important because now, let's say in this case we want to be able to figure out, we'll find, okay, well, how far are we going? Well, we know in this case the ratio we mentioned before, in this case that the, oops, sorry about that. Let's see, let me erase that part here. Bring this up. So we ratio 2 to 1. Well, here's the thing, all right? So our delta x in this case, our change in x is going to be 2 plus 1 pieces of. So we're going to take in this case our x2 minus x1 and divide by the sum of those values. So here our value in this case x2 minus x1, or so x2 minus x1, we're going to divide by 2 plus 1. And our y2 minus y1, we're going to divide by 2 plus 1. And so here, these values are going to be our change in x and our change in y. All right. Now, for unit-wise. So here, we're going to, now to find our p value, p will end up being our initial x value plus, because we're using 2 times delta x, and comma y1 plus 2 times delta y. Now, so it seems like a lot of formula here. Okay, so let's take a look at the next question, number 3. Let's use this idea here. So number 3 talks about mn, and here we see m is at -6 comma -3, and n is at 9 comma 7. Point Q lies on mn such that mq to qn is 3 to 2. All right, so let's talk about our difference in x's. So here, our difference in x. Well, that's going to be, in this case, x2 minus x1, which will be giving us 9 minus -6, or 15. Now, this really means, in this case, when we go from m to n, we're going to move to the right 15 spaces. Our difference in y, whose y2 minus y1, is going to be 7 minus -3. That's 10. So we're moving up 10 spaces. Why up? Because it's a positive y value. If it was a negative value, we're moving down. Okay, so now we know we're moving from m to n. We'll be moving to the right 15 and up 10. Now, we're told that the point we're looking for, point Q, is going to be on that line segment dividing into a ratio of 3 to 2, which really is 3 parts to 2 parts. So we're going to take our difference x of 15 and divide by 3 plus 2. Okay? And I'll take our difference of y, which is 10, and divide that by 3 plus 2. That means we're going to get, in this case, 15 over 5 is 3. And 10 over 5 is 2. Now, these are not going to be how much we travel, because we see, in this case, a ratio of 3 to 2. And the focus will be on the first number of 3. Okay? So, we see in this case, to find point Q, we're going to take our first x value, which is -6, plus 3 times 3. Okay? Now, where does that 3 come from? The first 3 here comes from the ratio 3. The second 3 comes from each piece of the units. Now, that would also mean for y, in this case, for the y value, we start off with -3, that's our y1, and we're going to add 3 times 2. Again, this 3 comes from that ratio piece, and the 2 comes from our number of pieces we've broken everything into. So with this in mind, we're going to just calculate this. So point Q is going to be -6 plus 9, comma, -3 plus 6, or the coordinate of 3, comma, 3. So the concept here is we want to figure out, what we want to focus on is going to be how we are going to see how we move from x's, how far traveling x and traveling y, break those distances into the pieces of the ratio. All right, and like any ratio problem, figure out multiplying by the pieces by the part we want to get though. So hopefully this has been helpful. All right, and I'll see you on the next video for the next 2 questions.